Connecting. Cool. I think we are live. A very good morning, good afternoon, good evening from wherever you are. My name is Sven Wegner, and today I'm presenting together with Team on Bold today the technical coffee chat. And the topic today is application of AI in the static code analysis industry. Now, I think last time we ended off the year with also AI in corporates, how startups contribute towards the AI strategy towards a corporate last year. And then we wanted to begin this year with how AI can help, especially in the static code analysis industry. Very simple terms, what is static code analysis? You can think of it as a grammar check in your source code. So whenever you develop any software, any product, you should ideally start with static code analysis. Now, a lot of people sometimes, unfortunately, do not do that at all and wonder later on why they have so many bugs in their product. But I'm not the expert here. We've got better people and more experienced people here who know this. Vishal, it's so great to have you here. Why don't you talk us a little bit about yourself, but also about Embold?
Yeah, hi, everyone. I'm Vishal. I'm the founder and CEO of Embold, and we are a technology company. We're headquartered here in Frankfurt, Germany, and we're super excited to share our technology and story about you.
Perfect, beautiful. Thank you very much. So today we also have Alison Ember here. Alison, you want to say hi?
Yes, hi. Nice to meet everyone. I work with Vishal alongside as the Chief Operating Officer, headquartered in Frankfurt, but currently in home office, like most of you. I think we've got a good presentation to walk you through, and we'll also talk a little bit about why Embold is different and how we're changing the industry. And we've got a couple follow-ups afterwards that we can share through Sven as well as others. And if you're interested, come check us out.
Beautiful. Thank you very much, Alison, for that great intro, and especially the follow-up after that. You guys don't want to miss out on it. Manas, why don't you introduce yourself and why don't you kick off with the presentation?
Yeah, hi everyone. Manas this side. I'm working here as at Embold as a machine learning engineer, and today I'm going to talk about say machine learning on source code, which might be quite a new thing for everyone. So I hope, as I am also thrilled with taking this session, maybe I hope everyone enjoys this session.
Great.
So who's presenting? Is it you, Manas, Vishal?
Okay, so I'm going to quickly, I hate presentations, but since you've been told to present, I'm going to throw it up. So can everyone see my screen?
Yes, sir.
Okay, great. So quickly gonna, just give me a second. Yeah. So I guess just to recap what Sven said, I think he described it very well. What is static analysis? Static analysis is basically it's finding issues in your software as you write code. So it is the traditional testing methodologies involve you develop the software, push it into testing, then you have a testing team or a testing process that tests your software against your specifications. But static analysis is a technique which has been around for as long as software is being developed. It's almost 50 years old, and it has just got better and better. So the limitation factor till 2010 in static analysis was it is a slightly compute-intensive process, and the tools that were being developed till even 2010, unfortunately, there were tools developed by experts for experts. But as you scale software development, it's not necessarily that the young engineer who's come into the team is as good as the most experienced, so he or she would struggle with the existing tools then. So that was one limitation. I mean, these tools were great, but you can have a great tool, but if you can't use it, it's of no use. So that was one thing. But as a technique, it's early feedback. It's the whole, as you write code, you get feedback in your software, or you get it through a tool like Embold. You actionize on the implementation, or at least you're aware of the issues that you're getting. But I like to have a caveat here that static analysis is slightly different from dynamic analysis, and people People often confuse the two. So static analysis is issues that are in your or that are discovered in your software, and which are based on your structural integrity of the software. Right? It is static. It's not. And dynamic analysis is basically finding issues that that could come in your software when you run your software. It's static, and that's why both are important. Security is a very important aspect. People get confused. Is it static analysis? Is it dynamic? It is both. So if you're, so Imbold is, we understand, we discover the quality of the software, but there are great tools which also find security issues statically. Imbold is also expanding its footprint, but I was just wanting to set the context of what is static analysis, what is security analysis. A lot of people talk about it, and both security analysis can be both dynamic and static. And so that's the whole concept. It sits into your, ideally it should be sitting in the IDE. It should be sitting, if I'm a developer, it should be sitting in my environment. So as I write code, it tells me what's good, what's bad, and give me hints on fixing it. Then, so it is interesting. So static analysis is so easy to implement, but it's so underlooked that it's unfortunate still that people realize the value of quality tools when they have a problem. And that is expensive. So it's been a struggle sometimes to share and encourage organizations that to incorporate this in this process. But we are seeing a lot of young developers and young engineers who are actually getting into this technique and adapting it. With that, what we want to share is there are tons of financial, industries which you see now. The issues of bad code is prevalent. It's all over the press, and I don't have to elaborate on that. And just to share on the flip side, if you have a good static analysis tool, it doesn't matter how big or small your team is. You can actually build mission critical software for some of the largest banks in the world with a small team, which is not necessarily the best in business. And that's what we've done in the past as Imbold. Just an example, we could build a very, very complex peer-to-peer lending platform for one of the largest banks in Europe, purely by by great engineers and a very strong static analysis platform. Just to give you an example that it can be used to build mission critical software very easily. Similarly, in automotive, everyone's saying automotive is the future car is going to be a computer on wheels. And the amount of software that's going into cars is just unimaginable. An average car today has, it's about 200 million lines of software. So the more lines of code you add, the more opportunity you give for poor quality to seep in. And unfortunately, just like in the financial industry, in the automotive industry, imagine if your braking software fails, people could die. So that's how critical the quality of software is. The only industry that's probably nailed it is airline. Therefore, planes don't crash. But the car industry and the other industries have to really, beef up. So again, another use case where tools like Imbold have really become very popular and are being used by companies around the world to build self-driving cars, mission and control systems. So as you see, it's ubiquitous across the industry. Whether you use it for a small project in your small team, whether you're building a web application for a company, or you're building mission critical software. Code analysis, static analysis has to be as a part of your arsenal. You cannot say it's an option, because what defines and determines a good and a great team, a good and a great developer, is how well they use tools available today to develop quality software. Coming to a little bit about Imbold, I'm not going to market the product as such, but just to tell you why we build Imbold. And there are static analysis tools in the market. They work really well. They do the job, but they are, as I call, tools built for the waterfall world. And I guess just to recap, I'm sure all of you are in the software industry. You understand the waterfall development process and the agile development process. In the waterfall world, you had a release which was 6 months. You had a development time, a testing process. So you could take your time. And if your tool was slow and it gave a lot of false positive or false negative, you still had the luxury of time to sift through the results and actionize on the results that you could do. But today the world's moved on an agile model. Everyone's, you got a 15-day release. Companies like Facebook, in a day they have 5 or 10 releases. So you can see from a 6 months release cycle, today you have companies like Facebook doing 6 or 10 releases a day. And when you have that velocity of software development, the static analysis tools or the tools that you need in development should be able to give feedback to developers really fast. They should be able to not only give feedback. One of the challenges of software or static analysis tools in the past are called the waterfall models. They give you a lot of data. Now, I'm not saying the data is bad. Or not, I mean, imagine you have you have an agile team. You have 15 days release or 30 days releases, out of which you probably have 15 days of development, and you hook up a static analysis tool in your pipeline, and it gives you 600 issues. So Vishal, you have 600 issues in your code. 40 of them are critical. 60 of them are major. 100 of them are minor. What are you going to do? What am I going to do? I'm going to just switch it off and say, screw it. I have no time to go through all these and figure out what's important or what's not, because I have a 15-day development cycle. And that is something which existing tools, the waterfall tools, as I call, haven't considered. They just give you a whole bunch of results. Some of them are really good, but if you can't use it, what's the point? And Imbold is, as you say, it's an Imbold, just like other agile tools, it's the next generation of code analysis where the other, I'll come back to this, other shortcoming of waterfall static analysis tools are, they give you a result on one dimension. So if you see my screen, you have, you can analyze code from multiple perspectives, right? You can analyze the code metrics, which is the implementation metrics of code. You can analyze duplication. You can analyze code issues. Example of code metrics is cyclomatic complexity. Example of code issues is memory leak. Cloning is duplication. So a lot of duplication in the code. And then there is a design and architecture. Pre-Imbold, you would need 4 different tools to cover your static analysis functionality. 4 different tools. You would need 1 tool for metrics, 1 tool for cloning, maybe 1 tool for code issues, and 1 tool for design and architecture, which means 4 different implementations. Plus, there would be no way of correlating data from these 4 tools unless you did that manually, which defeats the purpose of a tool. The purpose of the tool should be to make the user more efficient, more productive. And this was the other challenge that you had pre-Imbold. And often there is hints in data from multiple sources. And that is one. So when we decided to create the next generation of code analysis, we were developers in our past lives, and we saw these issues, and we said it is so painful to correlate data from multiple tools doing different things. Why not, have one tool which analyzes data on these 4 dimensions, because you work on the same source code, right? You do the same analysis, and you are able to get the results, and you're able to correlate it. You're able to prioritize it for the user, and you're able to give me these 5 big problems in my code, which I can fix in my 15-day release. So you see the change in the thinking that we bought when we build this tool. And this is something I would encourage. If you're building tools, DevOps tools, you're working with DevOps tools, it's not, the challenge is you see a lot of tools giving you a plethora of features, which kind of gets you excited. But once you bring them into your CI/CD pipeline in your development process, it just is so painful and expensive and resource heavy that it defeats the objective by which the tool was made. And that's, we've been frustrated with tools ourselves. So those are things we bought together. So Imbold is a tool which you don't have to buy 4 different tools. You bring the features of all 4 key areas, and we bring them together, and we do it faster and better with a great user interface, because we all used to iPhones and apps which are really, really well designed, and tools did not give a lot of love to the user interface. I don't know why they didn't show the love for engineers. We love engineers. We love developers. We treat them like kings, and therefore not only is our tool fast and better, but also it has a great user interface, because there should be pleasure in working. Now coming to what are machine learning and AI? So AI is very interesting, right? So I always define, when I say AI, I always take an example of farming. It is basically using advanced mathematical models based on concepts coming from biology, that's called neural networks, to learn from we are generating a lot of data today. People talk about big data in banks, stocks, airline, IoT, manufacturing, but you forget that an average development project today, has so many data sources. You got your repository data source, which is GitHub or GitLab. You have your issue management system, which is Jira. You have your logging system. You have your test data system. So every software project is now a big data project underneath. You have so many data sources. So if you see, we've taken the same thinking that we bought and changed conventional static analysis, which means we took, instead of buying 4 different tools, we built those functionality into one tool so that our users had everything under one umbrella. We've taken the same approach for the recommendation and big data, and what we've done is we've taken, so under each of these, there's the data sources. We've been able to convert them and learn from them to create a new rules engine which is better and faster for our developers. So that's essentially what recommendation engines. And I was coming to an example of what is AI, right? AI is like farming. You have the crops. The crops are the algorithms that you have. You have the soil, and you have the seeds. Now, if you have very good seeds, but your soil is unfertile, your crop's going to be weak. So if you take that example to machine learning, your seeds are the algorithms or the different techniques that you use. Soil is your data. So the richer your data, and the crop is your outcome. So this is what makes this is why makes software development a prime target for using machine learning and artificial intelligence. And that's why we got excited, and we are doing a lot of great stuff, which Manas is going to share more. And so I think with that, I'll hand it over to Manas to take this up, and I'll support him.
Yeah, sure. Thank you, Vishal. So maybe you can just keep on sharing the screen, and I would just continue with that.
Yeah.
Okay.
Okay. Can you share my screen? Can you see my screen? 1 second.
Yeah.
Just give me a second. Yeah.
Okay. Yeah, I think you have already spoken about AI, right? So we can just directly move on to the next slide, maybe. Okay. So I would just rephrase the problem statement, right? So we all know that a lot of vulnerabilities are discovered every year, right? And the number of vulnerabilities that are discovered are really rising. We must have heard about this solar wind attack, right? Or maybe in past there was something called as heartbleed bug. So what these bugs actually do is they cost a lot. I mean, financially and socially, right? So all these bugs might result in, say, system compromise or information leak, and maybe denial of services as well. So as we shall talk, right? So we have static analyzers and dynamic analyzers to find the security bugs. But the thing is, as he was speaking, there are many false positives that are reported. And so therefore this automatic vulnerability detection sort of thing in source code is sort of very challenging task and is active area of research. So as Vishal was talking about existing approaches, we have static analyzers and dynamic analyzers. So static analyzers basically whenever they are analyzing source code, they are not actually executing the source code, right? And with the dynamic analyzers, again, they would be executing the source code with many of the test inputs to identify the vulnerabilities. But the thing is, with dynamic analyzers, as they would be scanning executing the programs, right? So it would involve a lot of time, and of course the computational requirement would be also high. Then apart from these, there are something called as symbolic execution techniques, like which usually replaces the say input data with some symbolic values and then tries to analyze them over a say control flow graph sort of setup. And again, it is computationally expensive, right? And these might not scale well with say large programs. So to the rescue of that comes machine learning based approaches. So now, as we all know that the amount of open source code is really increasing a lot, right? So it is being referred to as often referred to as big code, or like it is in reference with big data. So we call it as big code. So now the thing is like there are data driven techniques possible to like find out or discover the
I'm really sorry,
vulnerability.
Manas. Sorry to interrupt you, Manas, but we cannot see the presentation anymore.
Oh, you can't? Okay, one second.
I'm sorry
Uh,
for interrupting you.
I think that spotlight option is on, maybe that's why.
Can you see now?
Yes, thank you very much.
Yeah.
Okay. So when we go with data driven techniques, these uh, I mean, the patterns in the source code, vulnerable source code patterns and signatures of vulnerable source code are automatically learned, right, with the model. So as you can see on the screen, we have like a very simple diagram which tells like what is the difference between say traditional static code analysis and machine learning based approach. So on the left you can see it is traditional approach for static analysis. Here, what we do is we have input as data and handwritten rules, and what we get from it is labels or the target, right? Whether a source code is vulnerable or not. So, if the source code is vulnerable, if it does not comply with the handwritten rules, and on the other hand, on the right side, you can see the machine learning based approach. So here we have to input data and labels, and rules are automatically learned from the data itself. So you can see the ML based technique has a clear advantage, right? You don't have to write handwritten rules, and I mean you have to keep yourself updated with the latest security researches, right? So yeah, I mean it is an advantageous. I'm not saying that it would be like completely replacing the static analysis, but both of these should be act as a complementary to each other. Okay, so I think we can move on to the next slide. Okay, so here I want to talk about code representation technique. So as I assume that the audience is technical, so if in any machine learning problem, right, so if we have say image classification, it is important to understand like how we represent images, because computers won't understand it in a raw format, right? So it has to be in some sort of numerical representation. Similarly, with the NLP pipeline as well, we have to convert the say tokens of the natural language or any language into some sort of numerical representation. So same applies with the source code, but the thing is source code when we are modeling source code, it is important to not only capture the syntax of the source code but also the semantics of the source code. Like if you can imagine say a sorting program, right? So if n number of developers are writing that program, they may be writing it in a n different ways. So they would be taking different variable name, right? Or maybe adopting a different logic sort of setting. So it is very important to capture both the syntax and semantic. And source code is like highly structured data. So in a typical natural language processing pipeline, we would just remove say commas or punctuations or stop words, right? But in terms of source code, even a bracket or a semicolon is of equally importance. So the challenge is like how do we represent the source code? So I would like to start with a simple token based representation. So this representation is like simple and very much similar with the natural language processing pipeline. So we simply treat the uh, source code as individual tokens, and we just apply some sort of say word to X sort of technique and convert it into a numerical format. So this is very basic representation, and this would of course capture the syntax well, but it won't capture the semantics of the source code. So here comes another technique which is based on the abstract syntax trees. So people who are aware about compilers may be knowing that compiler stores the source code as a intermediate representation, which is AST. So yeah, if you can see on the screen, there is a diagram representing a AST for a simple code line, which is like A is equal to B multiplied by 2. So you can see how do we break actually the source code into a AST. So we have an assignment operator, then we have like left nodes and right nodes. So A and then a multiplication operation, which is again composed of B multiplied by 2. So this is a sort of AST representation, and we can just, I mean, represent source code in a tree format, or you can see another approach which is token based. So we will talk about a few more representation techniques, and probably then we can compare between various representation techniques that are there. Okay, so maybe we can move on to the next slide now. Okay, so here we have another two approaches. So the first one is you can see is control flow graph. So this representation is like capturing how the flow or how the control flows through a program. I mean, in your undergraduate classes, many of us have drawn those flow charts, right? So it is actually a representation to capture that relationship. Like if there is a if statement and if there is a for loop, right? So how the flow of the control would happen from if to for. So that sort of relationship can be captured with the control flow graph. Again, there is a program dependency graph. I mean, it's another representation which captures a relation between like how one statement of a program is dependent on the other, right? So if there is a while loop, right, with a control variable of say I is less than equal to 11. So where that from where this that value of I is coming, so that I is, I mean, the value of I is dependent on some other another statement. So that sort of relationship is being captured using program dependency graph. So again, if you can see with the AST or the control flow graph or the program dependency graph, we only have to like we are only able to capture one of the dependencies at a time, right? Or one of the representation. Say either we are having the control flow information or we are having the program dependency information, right? But since we if we go on with one of these representations, we might I mean skip few of the semantics of the program, so our predictions might not be very great. So with that, maybe we can move on to the next slide. Okay, so here we have this code property graph. So it is a very interesting data structure. So if you can see on the diagram on the left, so you can see it can capture all the three nodes and edges of uh, the program, right? So it can capture not only the AST but the control flow information and program dependency graph information as well. So this sort of data structure is like very efficient, and we have tested this out, and it is really very efficient in representing the syntax and semantics of the source code. So it really improves the predictions and yeah. So basically, it has a set of nodes and a set of directed edges. So with the directed edges, we are able to capture the relationship between, say, if a function has a local variable, so has a kind of relationship, right? Or say contains sort of relationship, and each edge is, labeled edge. So every node represent either one of the AST node or program dependency or control flow node, and each edge also has a meaning behind it. So this sort of representation is very efficient in capturing all the syntax and semantics information of the source code. On the right, you can see there is a sort of custom representation. So this sort of representation was developed by Microsoft. So it is based on the three properties, that is last used, last write, and computed from. So again, they create nodes and capture these sort of relationship using edges. So yeah, we are not limited to these sort of representations. We can just make out our own representations. But to sum up, we have to say that graphical representations are better form of capturing the source code information. Okay, so once we know how to, I mean, represent the source code, we have to define how do we get the labels for vulnerable source code, right? So this is again this could be a challenging task, since data availability is always an issue, right? So labeling can be again done by static analyzers and say verified by security experts to remove any false positives, or maybe it can be done using crowdsourcing, or there are other efficient techniques which are more of a automated techniques, like we can do a code clone sort of detection. We can apply code clone detection sort of technique to identify vulnerable code from, say, a vulnerability database, right? Or that is a way to identify vulnerable source code. Again, the last one is very interesting approach, and we also follow it in our recommendation engine. So we have this. We have to correlate between the issues in issue tracker, say Jira or GitHub issues, with the bug fixing commits. So whenever a developer fixes a bug, he might be using some sort of notations, right? And might be mentioning some sort of issue ID. So we have to correlate between the two and get the desired labeling. So now the final task is of modeling source code is pretty easier, since we have the code representation technique and labels. We can just model it. So if we are using a simple token based approach, maybe we can use some sort of transformers or RNN based models, right, to model the source code. Or otherwise, like, there are other models. These are really very complicated models, so we won't go in detail with these. But to name a few, there is EST neural network, right? And there was, to model the graphical structure, we have graph neural network. Those are getting like highly buzzword these days. And again, like, if you could see, the commits have a hierarchical structure. So any commit affects multiple files, and those multiple files have say few lines added and few lines removed, so multiple hunks. So those follow a hierarchical structure, and we can apply hierarchical neural network on that. So as per our experience, graph neural network based solutions gives better results. Okay, so we have modeled the source code. Now it comes to deployment. So deployment can be like if we want to keep it close to developer, the best thing is like to deploy it in an IDE. But of course, we can always provide a cloud-based solution, right? But only deploying is not possible. Not only thing that we need to focus on. We need to focus on continuous improvement as well, because like the development environment is changing rapidly, right? I mean, there are newer libraries or the newer versions of existing libraries, or even newer versions of, say, languages that are coming up rapidly. So we need a mechanism for, say, developer feedback on predictions of model, and that data can be used to just retrain and improve the existing models. So one major challenge with deep learning, I mean, as identified by many, is like the deep learning based model or machine learning based model in general are, say, black box models. So how do we convince a developer? Say, if I am saying that to a developer that your source code is vulnerable through a machine learning model, how do I convince him that where is the uh, actual bug? So in case of static analyzers, they are pretty good at pinpointing the location. Like they would say line number so and so is buggy, right? But with the machine learning based approach, we have to figure out ways to, like, how to convince developers that a particular code is buggy. Otherwise, developer might not, or simply ignore that suggestion, right? So there are ways. A lot of work is being done in explainability. So I mean, we can take the way it works is like we can take the output of the last layer of the model, or say attention feature weights, and then superimpose a sort of heat map over the original source code. So the structure that you would get is like you can see on the right hand side. It's sort of highlighting. It's sort of a heat map, right? It is highlighting the most vulnerable part in a darker color. So these sort of explanations are necessary to convince developers as to like why a particular source code is vulnerable. So yeah, I think we can move on to the next slide. Okay. So what are the, say, advantages of ML based approach? So one thing is that it can learn hidden patterns very easily, right? We don't have to depend on humans to find vulnerable patterns in source code. Since this is a data driven approach, and it is like easily able to get all those patterns, and it can just scale well with the feedback mechanism that we discussed. So once we have a efficient feedback from the developers, we can just verify it and retrain the model and improve it further. And there is of course no need to like write constantly new rules. It would be evolving as with the developer feedback, or say as the new data comes in, it could be improved, right? And lastly, explainable models, building explainable models give more confidence. So recently there has also been a paper for explainable graph neural networks. In the past, I mean, with the graph neural networks, explainability was non-existing, but now that approach is can be applied to the predictions of graph neural networks as well. Okay, so finally, I want to talk about few other interesting applications of machine learning on source code in general. So static analysis is like not the only thing, right? Which can, I mean, machine learning in general can be really helpful to, I mean, make developers more productive. So there was I think, a report from in 2019 from Stripe. So they just estimated around like how much do a company lost or we lost per year due to technical debt or due to uh, developer productivity issues. So it was huge. It was like around $87 billion. So I mean, machine learning could on source code could really help developers build a say better. I mean, to be more productive. So here comes the naturalness hypothesis. So this was proposed by a 2017 paper uh, by Ellamenis and a few others. So it says that software is a form of human communication, right? So whenever I write a software, I would provide comments and so that other person can understand. And of course, the developers follow few sort of idiomatic structure, right? I mean, we have say pattern in writing code. So that sort of patterns can be easily captured using machine learning techniques. And hello, sorry. So yeah, as we talked about, like there is no lack of availability of data in terms of source code. So we have this GitHub, right? So entire GitHub code is actually hosted on Google BigQuery. I mean, using Google Bigtable and can be queried using Google BigQuery to get the data set. And with the recent advancement in NLP, with the coming of transformer models or say graph-based models, this is like a beginning of a new era where software development tools are could be really enhanced. So this hypothesis inspires us to like build more developer-friendly tools. So to name a few, you can see maybe in the slides. So in GitHub, we have seen searching is like very poor, right? So we can do a semantic code search. So that would be really beneficial. Instead of say token based searching, it would be semantic searching. So I can find out all the say implementation of a bubble sort algorithm or maybe any sort of algorithm, right? Similarly, we can easily find if we represent source code as a vector in a say embedded space, we can easily find out duplicate GitHub repositories, right? And then of course we can learn from the coding conventions which developer or a company might be following to suggest better variable names or better identifier names, which is sort of very challenging problem. Like often developers find difficult to like find new or better variable names. Similarly, in loosely typed languages like Python or say JavaScript, maybe we can find out say type hinting of variable, like what value is really expected, whether it is integer or character, what sort of. Similarly, there has been works on say source code summarization for automatic documenting the source code. Then yeah, I mean there are host of other features, maybe like code completion using large language models like GPT-2, right? Or as we would be explaining further, like program repair and bug detection sort of techniques. Then there is also been work with the program translation, like we translate English into German or maybe French, right? Similar way we can do translation of programs from C to Java. Again, a few important or like interesting applications, like given a natural language, the program should or the model should output the SQL query or say bash commands. So these sort of applications would be really useful to any developer. So last application is like detecting buggy commits and suggesting a fixes for it. So this we already have, and many of the applications we are working on as well. So the last application, that is Embold's recommendation engine. Maybe Vishal could take over and just explain it in a better way what it exactly it is.
Yeah.
Thank you very much, Manas. Thank you very much. I think quite technical. I think I'm happy that I'm staying in the business side of stuff, But this is super exciting, and I can see a lot of comments here as well. I think everyone is keen to see the platform. But hey, Vishal, why don't you talk us a bit through about the continuation, please?
Yeah, so recommendation is a very interesting feature that we have. It's still in beta and it works for languages like Java and C++ for now. But what it does basically is it ensures that, or it endeavors to ensure that you do not make the same mistakes that have been made in the past in the repository. That's what it does. So the way to simplify it, it takes, so basically what do you have in your issue system, right? If you have a Git repository and if you have an issue system, issues are unwanted behaviors, right? You have features or issues, it's a bug or a feature. So if any repository or any project historically has a whole bunch of issues which have been logged meticulously by developers, which is logged in Jira or Asana or whatever you have out there. So what you can do is, very simple. You can take a neural network and train it on all past issues that have come in the software in a repository, correlate it with what changes in the code created the issue, right? It's very simple. You have code in t equals 0 today. I make some changes, I commit, and someone tests the code and finds that it has a bug. Then what happens? So for whatever change I made in the code between T0 and T1, that change effectively created the bug. So then it's reported to me and I go fix it. Then there's another change that happens. So first there was a source code pre-bug. Then I added something which introduced the bug. Then someone raised a ticket describing the bug. And then I made the changes and hopefully the bug closed. So what we are able to, what the neural network does is it takes that information and transforms that bug as a rule. What is a rule in static analysis? The rule is an unwanted behavior. So we're able to take your code data and convert that into a rules engine. So basically ensuring that you don't make the same mistakes. And we've heard from some of our customers that sometimes up to 40% of issues that come in a release has come in the past and someone has fixed it. Now imagine if you had a smart recommendation engine which ensures that you don't make those 40% issues that come up, you could literally turbocharge your development velocity. So that's the RE feature, but from a technology perspective, without being too salesy, that's what it does. You just set it up, you mine your history, you mine your repository, and it builds a knowledge base over an hour or two, depending on how big it is, and then it feeds it back to. It even tells, you can predict the bug. So it's like I'm writing a piece of code in my IDE and it flags, hey, Vishal, you're about to introduce an issue which resembles an issue which was logged in Jira. So I have that correlation. And then if that issue is fixed, it also tells me how this issue was fixed and also who fixed it. So that's the part of Imbol's recommendation engine. Of course, there are some constraints that if there are less than 4,000 or 5,000 commits, so as with any AI, right, if the data is not enough, the learning is very weak. So yes, so this doesn't work on a brand new project or a small project. It has to have at least 4,000 or 5,000 commits in order for it to have some rich learning. And that's the recommendation engine that we have. This is how it works. So if you can see my screen, so basically we look at it is trained based on issues, commits. We do the diffs, what changes in the code created the issue, what changes in the code fixed the issue, and you can validate this very easily, right? You can take a piece of code, over 10 years, take the Linux code. You can use the first 8 years to train the model and have it predict, and then look at the issues today and see if the issues that the neural network is recommending has been logged. So that's how you can test it and fine tune the model. So that's very exciting. So today you can train a neural network through issues system like Jira or GitHub, but nothing stops you from extending it to learning from everything about the code, right? So if your commit is the center of the universe, you can learn from the feature because of which I created that commit, or an issue which I acted on the commit. Also the logs, if this commit or this piece of code ran in production, what was the logs that came out, and many more, right? And therefore you you train the neural network to be perhaps the smartest developer in your team. That's the goal. That anyone comes in, switches on the network, and it almost becomes like Siri or Alexa, and it knows everything about the repository in which you're working on, knows all the history, knows all the mistakes that have been made, knows all the people who worked on it, knows every system that touches that application in the repo, and it just sits as your assistant so that you can build fast without worrying about making fast mistakes. Of course, you can make new mistakes and you learn from it, but the improvement is really exciting. Yeah, so that's the presentation part, and yeah, we'll be happy to take questions now.
Thank you very much, Vishal. Thank you very much. Yeah, that's perfect. You finished sharing the screen. Anybody have any questions? If you want to come on stage, you can raise your hand. There's a raise your hand button there on the right. Oh, there you go. We've got a raise hand. Let me guess. Rodion.
Hi guys. Well, maybe very simple question, or can you also maybe demo some of these features, show how this works? Is it,
Yeah.
or is it kind of out of scope of today?
Let me see if something is there.
Thank you very much, Rodion.
And one more question: is it already integrated with stuff like IntelliJ IDEA?
Yeah, we have a plugin for IntelliJ. Not the recommendation engine, but we do have the plugin for IntelliJ, yes.
Okay.
It's coming soon.
Say it again?
It's coming soon.
Okay, great. Okay, thanks.
So while I'm going to pull up a demo, but keep throwing those questions if you have any more questions.
We have a couple of more people who raised their hands who would like to come on stage. While you look at it, should I bring them on stage?
Yeah.
Perfect. So we've got Alvin providing a mic now. Alvin, the stage.
Yes. Hi, Vishai.
Hi.
Yes, Vishai. I've actually you also have with the platform, with the static, with your platform and with your resources. You also work with enterprise. You actually have a solution for enterprise.
Yeah. We have about we some of our biggest customers are large enterprises who use Imbol as a part of their development toolchain.
All right. Okay.
So is there any specific?
Yeah, I'm actually the reason why I'm asking about enterprise. I'm actually looking at more of manufacturing. That is the fast moving consumer good industries. And
okay,
have you ever worked with that kind of industry with your solution?
Yeah, we are working with some of the largest retailers in the world actually, and we have experience. Their stack is classical Java, JavaScript. So it doesn't really matter what the domain is, but it does. It works with the programming language. So yeah, we do work with a lot of enterprises.
All right. Yeah, that's all.
Do you know the stack that is being used? And I have been able to pull up the demo, and I'm going to just share my screen. I'll just show you how this works. Can everybody see my screen? Okay, great. So I have my Imbol set up, and I'll show you. So as you said, it's great to look at. There's a lot of scores. You can see the Imbol score is a quality score that we've developed. It's a relative ranking. And then I'll show you how that works. So give me a second. Yeah. Okay. 1 second. Okay. Oops. What happened? Okay. So I'm going to share my screen again. Yeah. Oh, yeah. Okay. Can everyone see my screen?
Yes, yes.
Okay, so I have an account. So this is a repository. This is Kafka. There are a couple of versions that have been set up, and I'll show you how the learning recommendation engine works. So if you see, this is the entire commit history. As you can see, there's a commit ID, and we've already trained this. This has already been trained, so I don't have to waste time. And it immediately flags saying, Vishal, this commit has 3 change files, and the neural network predicts 2 issues. So we have not written any rules. It has been trained by Kafka's history. And I go into the change, and here it is. So it says, so imagine this in your IDE. It says, Vishal, you are about to create this line could create an issue which resembles an issue that has been, it has come in the past. So it tells me, instead of time.sleep.retry back off, it asks me to replace that with this module. And as you see, this is this resembles an issue that has come in the past through Kafka, and it takes me to Jira, and I can see the issue. So this is an example of how the neural network works. Just give me 1 second, guys.
Vishal will be right here with us. Sumit, you've raised your hand and you're on stage. So while we wait for Vishal, do you have any questions towards the Embold team?
Yeah, I'm back.
Oh, okay, perfect. So Sumit, we'll take that question later.
Yeah, so as you saw, I had, this is my commit history, and it has found 2 issues which has come through the neural network, and I haven't written any rules here. This commit, it says you have 4 potential issues. I click on it, boom, it says you could perhaps change this on join, complete, generation, snap member assignment. It says just add protocol name here. So of course, I mean, as I said, you have to use developer judgment, and it gets better and smarter as it trains more. But at least it gives you a hint and an immediate access to historical data, which can be very useful, especially when you have new developers coming in, a rapidly scaling team. It can be useful. Does this answer your question? Rodion, does it answer your question? Okay.
So I think, yeah, Rodion dropped off from stage. Okay, Rodion raised his hand, so let's bring him on stage.
Thanks. Yeah, I just wanted to say, yes, it does. Now it got more clear what kind of, looks interesting. Thanks.
Sumit, you had raised your hand as well. Do you want to raise your hand again and come on stage?
Hi Vishal, hi Manas. Thank you, Sven. Hi Alison. Glad to be here. From a personal experience, definitely Embold has been of great help for my startup in the automotive domain. The question I basically wanted to ask was how effective or how efficient Embold can be for an individual or for a freelancer, considering that there is AI and the machine learns in terms of the development or the code, the static code of any developer. So, for a freelancer, how effective is it?
Okay, so good question. So today, unfortunately, we are not. this is not available on the cloud, the neural network, and for a very simple reason. It's we don't want to. We'll be transparent. It's very expensive right now to offer it on the cloud because the inferencing and the processing is quite compute heavy. That's why we right now it's only being offered if Embold is installed on your premise, then it works absolutely fine. However, we are working on bringing it to the cloud because if you see a cloud is very efficient, right? We have over 5,000 accounts, we have over close to 10,000 users using it, and it starts at 10 euros a month, which is completely nothing. It's completely affordable. So we're trying to bring value to our cloud customers through our neural network in a model that we should have something by mid of this year. But today it's not available on the cloud. However, it's available on premise. So for medium, smaller enterprises who are interested in installing this on premise, this is available. It's still in beta because we are still fine tuning it. But that's the update. I don't know if that answered your question.
Yeah, absolutely. And for freelancers, there's always an option for cloud deployment, right?
Yeah. It's very popular. It's actually really, really popular with freelancers, small teams. A lot of them have this as a part of their toolkit, just like how they have GitHub account or a Jira Atlassian account. And it's very affordable. I mean, cloud packages, starts at, we have a free version, so you can start off with free, and then as your lines of code increase, you can start off with something as low as 10 euros a month.
Absolutely. Thanks. That answers my question. Thank you so much.
I think it's a very fair point, which Sumit raised as well. So Embold as a platform, I believe, is an enterprise class quality assurance platform, but it is also startup friendly. And you don't get to see that a lot in those enterprise class software platforms. They're either made for the big enterprise with licensing models you cannot afford as a startup. Whereas, and this I've seen in the past as well, that Embold, yes, it's a great enterprise tool and it's got a couple of really great ISO certification. But then it's also very startup friendly. And I think the versatility of being able to, like you buy your Slack or how you get onto GitHub, you just swipe a credit card and get it done. And then for the enterprise as well on that level. So I think it's a really great platform. Ourselves, even though we're an incubator, we do have some software as well. We made it our mission, especially in January, to have clean code wherever it is with us. But we also highly encourage our startups who are in our portfolio to use Embold to clean up that software, make it ready for the next release, so that when you go in front of an investor, and I don't think this happens a lot, but it sometimes happens, you want your product to be clean and functioning properly. For that, you will have to look at your code quality at some point. It is not enough to do field testing or to see, hey, let's code something, put something together and see if it works at the end. I think that is all very old school. I highly encourage you guys to look at Embold. For those of you who are not here on Airmeet, but who are listening to us on YouTube, you can access Embold very simple. You go to www.embold.io. The team is here. So for those of you who are still here, I know it's pretty late in India. We are not done yet. After this presentation, we can go to the networking lounge and we can hang out around over there. The lounge itself will be open for the next 8 hours, so whoever wants to stay there for the next hours, you're more than welcome. I wanted to say thank you, but before I say thank you, we have one more person who wants to come on stage, and that is Vinod.
Hi, Vishal. So, Vishal, I have two questions over here. One, what is the stack right now that Embold can work with?
So I think we support 13, 14 languages. Is that what you're saying? Which languages can we scan? Or what is the infrastructure on which you can install Embold?
Question is, which is it can scan?
Yeah, so it can scan any. I'm up to I think 13 languages. But in full honesty, the languages that we really show value are Java, C, C++, C Sharp, JavaScript, Objective C, Android, Java, TypeScript. So that's where we really are very powerful. But we do support 13 languages. today.
Got it. And the second question is that, like, how many million line of codes does it take for Embold to start learning and assessing the pattern and to be starting to be effective? Like, of course, it has to learn. So, how much does it need to learn?
So it doesn't depend on the size in terms of lines of code. It depends on how many commits your historical repository has had. So you can have 1,000 lines of code, but if you've had 4,000 commits, then it's good enough for it.
Understood. Thank you.
And that's just the recommendation engine component that is related to the AI. The base of our platform, the static code analysis that is rule-based, we don't have limits on that.
Understood. Really exciting.
Vinod, I understand, like you said, you're from the gaming industry, right? And I'm sure that this very much applies to the gaming industry. Like, I'm not a developer, but I'm sure that you might use C, C++, and that is it's a heavily supported language within Embold as well. So if there are any gaming developers out there in the audience and you guys want to test your games and not put glitches, which I'm not going to say out loud here, but if you want to avoid glitches, I think you should also start implementing Embold for your games as well.
Oh, absolutely, Sven. So one of the big problem with games are like it cannot be QA'd the way we do QA for a regular piece of software. Most of the times the QA is in runtime and in manual testing mode, and there's not much of a scope of automation testing out here. So something like Embold can actually be sitting on the static side. It can actually assess the code and see the code if it is actually going and making mistake or not. This is how I'm looking at it right now. And it can actually help us reduce the number of mistakes that will come out for the QA to actually trap it. And when it comes to games, QA is a nightmare, to be honest.
Actually, for gaming industry, I don't know. I mean, I am not a gamer. I don't develop. I just looked at some code. A lot of issues come in memory mismanagement. If correct me if I'm not right.
Indeed.
Yeah. So the moment your games are memory mismanaged, then everything goes for a toss, right? Everything is so real-time dependent, and everyone is dependent on the other library that's rendering, and then if one small function just doesn't close the resource after doing something, it just creates a spiraling effect, right?
Indeed.
And that is one of the biggest powers of Embold. And usually today, if you are a gaming platform, you will do dynamic analysis, right? Basically, they do dynamic analysis. They check memory, performance, consumption. But we have got some dynamic traceability into our CC++ and are also building metrics which can give you memory management footprints very, very intelligently. We're doing this for automotive, but it applies even more for gaming because gaming is real time, right? And we have seen where you just depend too much on, as you said, manual testing and runtime testing. But that's treating the patient when the patient is sick, right? That's hard problems. You also need to create a good internal architecture, internal code structure, so you reduce the chances of runtime. So we say that runtime is symptomatic of poorly written software. So we would be happy to run some open source scans with you for the gaming community in India, and even have a special program for them, because that could really make or break a small gaming company, right? As we've seen globally, what happens when you don't achieve your quality goals.
Oh, yeah, indeed. All right, thank you, Vishal. Thanks, Alison.
Sven, we can't hear you.
I forgot to unmute myself. Yes, we stop at 5, but that is totally okay. I think it's a really interesting topic. I would suggest, first of all, thank you very much, Embold team, that you're investing your 1 hour now in this session. Thanks to all the attendees for attending our session. We are not done yet. I can see people leaving. Please do not leave. We are actually having our networking tables If you want to hang out and ask questions to the Embol team, you can do so at the networking table. Yeah, again, thank you very much. I hope that we'll have a part 2 where we maybe go a little bit deeper into the Embol platform. I think that'll be super cool if we could do a live product and maybe get some code tested in live. That'll be cool. Having said so, thank you very much.
Thanks for having us.